So then the terms here would be 5c squared, that's one term. Another term would be 7d, that's another term. Now we're going to identify the coefficients. Now we have two things here or two terms that have variables. So in the first one, 5c squared, and the second one, 7d, the coefficient here would be 5. That's a coefficient. I'm going to abbreviate for it. And then 7 here would be the coefficient. And then lastly, do we have any constants? Do you see a number without a variable? Well, we have 7d and 5c squared, but they both have variables, so therefore we don't have a constant. So no constant. Okay, that was number 10. So no constant, and then 5 as a coefficient, and 7 as a coefficient, and we have two terms, 5c squared and 7d. Now moving on to number 14, it says describe and correct the error in identifying the terms, coefficients, and constants in the algebraic expression 2x squared y. Now the student thought that the terms in this expression 2x squared y were 2, x squared, and y, and that the coefficient was 2 and there were no constants. Take a moment to see why does she have a mistake in this answer? Well, she was correct in thinking that 2 was a coefficient of the expression, and she was correct in identifying that there were no constants, but are 2, x squared, and y really terms? Are they separated by an addition or a subtraction sign? No, right? They're being multiplied because they're right next to each other and they don't have a sign in between them. So therefore 2x squared is only one term. One term altogether. But it doesn't mean that 2 and that x squared and y are different terms. That is not the case. That is not true. This whole thing is only one term. Moving on to number 25 through 28 and 39. Whoa. Okay. So it says, evaluate the expression when a equals to 3, b equals to 2, and c equals to 12. That means that we have given fixated values for a equals to 3, b equals to 2, and c equals to 12, meaning that these letters represent these numbers, and this letter b over here represents this number 2, and this letter here, c, represents 12. So if I say c is the same thing as 12, and b is the same thing as 2, and a is the same thing as 3. Now for number 25, 6 plus a. So we have to substitute the value for a, right? Because a could be anything, but here they're telling us that it has a value of what? 3. So we're going to substitute that value because it was given to us into this expression. So we have 6 plus what? 3, right? Because a is equals to 3. So 6 plus 3 is 9. And then b times 5. Well, what is the value of b? In this problem, they're giving us 2 as the value for b, so we just go ahead and substitute 2 times 5, which is 10. 27, they're giving us c minus 1, but what is the value for c? The value for c in this problem is given as 12, so we're going to go ahead and substitute that in. So it's 12 minus 1, which is the same thing as 11. For 28, we have 27 divided by a. And for a, we have a equals to 3. So we're going to substitute the value of a as 3. So 27 divided by 3 is what? 9. And remember that for this one, you can also write it as 27 divided by 3, which is 9. So this number here in the front always goes inside of the little division sign. Always remember that. And then for number 39, we have, oh, it's missing a little part of the problem. 1 second. Okay, so it's 10 plus 3m. Okay, so it says, after m months, the height of a plant is, what was it? It is 10 plus 3m. This is given to us in the problem. After m months, the height of a plant is 10 plus 3m millimeters. How tall is a plant after 8 months or 3 years? Okay, so let's remember that in this problem, m, the variable m represents what? It represents months, right? So m equals months. And they're telling us that the height of a plant is determined by this little expression. 10. Okay. That wasn't supposed to happen. Okay. 10 plus 3m. So the way to find the height of this plant is by this little expression, 10 plus 3m. And m represents months. So we're trying to find out how tall is the plant after 8 months and 3 years. So we're first going to go ahead and work with the months, 8 months. So if m represents months and I need to find 8 months, we're going to go ahead and substitute 8 for m because it's 8 months, right? We're going to substitute that in, and m represents months, remember? So first, going back to GEMDAS, we first have to evaluate whenever we have parentheses, right? Or grouping symbols. So 3 times 8 is 24 plus 10, which is 34. So we could say that it would be 34 millimeters, right? It would grow that much because they're telling us how tall is the plant after 8 months. So now we're going to go ahead and find for 3 years. But this one's a little bit tricky because we have m representing months, right? 10 plus 3m, and m represents months, but they're trying to find out for 3 years. So 1 year, how many months does 1 year have? That's 12, right? 12 months. And that's only for 1 year. But I need to find for 3 years. So I would go ahead and multiply. So 3 years times 12, that would give me the total amount in months, right? So 12 times 3 is 36. So I'm going to go ahead and say that it would be 36 months, right? For how many years? For 3. And I did this because I need my number to be in months. I can't just plug in 3 because that's years. And m represents months. So 12 months are in 1 year. So therefore 3 years times 12 months equals to 36 months. So now I can go ahead and plug in 10 times 3, and then we plug in 36 months.